plus 2.8362 minus 0.5 squared times by 0.5 times by 0.5 times 2 is equal to 2.7289. Okay, so this will be equal to 14.2241 plus a 2.7. 14.2241 plus a 2.7289. Come on, make it work. 16.953 inches cubed. So what did we learn? Treat as are we clear? I did not know. I did not do it in my notes. I did not know. Okay, that's why I'm a bit nervous. Anyone, any questions so far? We're okay? Evans, we're good to go? Okay, I give you a break. Okay, I'm not going to ask you difficult question. Yes. Yeah, so later on, we still have to divide by 2Q, right? We still have to divide by 2. And make sure a question like this don't come out. Okay? Can't tell. I need to analyze first. Okay, I don't like to throw bullshit at you. Okay, let me think. So you are talking about 3 webs, and they are all continuous. Okay, so sidetrack a bit. Like this. So what will happen is we follow the rules. This is one possibility of terminus. The other possibility, this is the other possibility. Can't tell. Let me do some calculation and put into finite element to see whether my answer is the same as finite. Then I can tell you. Are we clear? But you still design the criteria based on what? Major web what? Controls the what? The flow. So terminus can, over here you have how many terminus? 4 terminus. Over here you only have how many terminus? 2 terminus. So I can't tell you which is right or which is wrong yet. Okay? But you still have to design your what? Your shear flow. We clear? Okay? Don't worry about this question. It's just something by the side. Okay? It's a good question though. Right. Any questions? I think, do you all need more examples about thin wall, or you're okay, you're good to go? If you were to see a problem like this, I posted the solution already, okay, for you to see, okay? Are you confident enough to do a problem like this, yes or no? Right? You have confidence. That's the most important. I want you all to have the what? The oyster sauce in you in such a problem, okay? Now, the next topic that I'm going to teach is longitudinal shear analysis. Okay, so this is the last topic we are going to handle in shearing stress. So we are going to analyze the strength of joints in shear loading conditions. And I like to look at this diagram. I posted this diagram on Avenue to Learn. If you could copy it. Okay, good. So you have a diagram like this. If I were to draw a transformation, X, Y, and this is rotation about Z. So if this is a cross-sectional view, this will be your Y, this is your Z, and this is your rotation about X. Honestly, I'm not afraid of him. You're saying I look like freaking Bruce Lee. You real shit with the family. Wait. Why I'm doing this? Because I want you to learn the concept, not that I want to pick a fight. And this might help you, okay? So this I can reach him. When he does this, I only can do this. Can you see that, right? Can you see that, right? It's impossible, right? So what can we do? Where were you at time? No, don't go lower. Don't fight properly. Don't like. Even when I do that, I can't reach it for crying out loud. I biomed student. Huh? No, where will you attack? This is gonna happen. Yeah. Huh? No. So I confront. Maybe we got road rage. Okay, he cut me away. Like a blur. Right? So then when a fight happens, where are you gonna hit? Emotionally. Where? You remember, we have no guns. Hey? So you are going to hurt. So can you stretch it? Yeah. You have to hit somewhere that you can reach. I can't touch any of this. When he put his hand out here, I can only do this. The elbow is the weakest point of his body. So if I do this, you get me? At least I could reach. Are we clear? So what I want to hurt is where? The joints. Are we clear? Thank you so much. Okay? Are we clear? So it's a joint that's going to induce what? You will always remember this. Okay, I'm not asking you to memorize crappy textbook. The joint will always fit. I remember that tall guy pushing his face. Yes or no? So the only way for me to attack is where? The joint. You see someone bigger than you have to be outsmart the person. You attack with the what? Joints means where? Joints, joints, joints. Or any part that is joint, go for it. But when you go for it, you have to be very accurate and make sure once you go for it, the burger cannot stand up. If he stand up, you are dead. Are we there? Now, this structure over there is made of 4 different parts. The top and bottom flange, you can see, are separated from the vertical wedge. Can you see that? Now, let me ask you a question now. Where were these failed? At the joints is where what? Failure will what? Occur. So failure will occur where? Failure will occur this is where failure will occur. So this is the only topic in solid, we call it solid mechanics. Okay, we don't call it this. Solid mechanics, okay, this is the only topic that you will learn on how to detect failure besides shear force and bending moment. Okay, so the shear force and bending moment diagram, right? When you look at the shear force and bending moment diagram, it will only tell you in this view where the structure will what? Will fail. Yes or no? If you look at your shear force and bending moment diagram, if we look at our shear force diagram, the shear force diagram that we sketch will look like this. Am I right? So this is P over 2, over here is minus what?